Plotting points using polar coordinates. All right. So polar coordinates, please watch the last video if you haven't already. Polar coordinates are coordinates of the form r comma theta, r comma theta, where the r value is a distance out on the terminal side of this angle theta. So graphing paper for polar coordinate systems, right? We talked about this before, looks a little bit like this. There's a few things that can happen here, and I want to talk about them before we even try to plot points. And it's the fact that either of these numbers can be positive or negative. And we need to know what to do in the case of it being negative versus positive. So with theta, this works the way it's always worked. If theta is positive, you move, where is it? If theta is positive, you move in the counterclockwise direction, right? So positive angles move counterclockwise, negative angles move clockwise. That's the same as it's always been, plotting angles in standard position. The R value is where it gets a little funny. So we can draw an angle, we can draw the terminal side. And here's what happens. If your R value is positive, then you move towards the terminal side. You move outward on the terminal side. Here's the terminal side. We're moving outward on it. However, your R value could be negative instead of positive. And if your R value is negative, you would draw your terminal side, right? But instead of moving outward on the terminal side, you move in the exact opposite direction, the opposite direction of the terminal side, and that's how you plot a point. So you can kind of see here, this is the point 4 comma 3 pi over 4. So you go to 3 pi over 4, draw the terminal side, and then you're going out 1, 2, 3, 4 units. Sometimes I like to draw little circles here on the lines, just because with polar coordinates, it can be kind of hard to tell what units you are outward. But you can see here, this is the 4 right here. Over here, this is 4 comma negative 3 pi over 4. So negative 3 pi over 4, it moves backwards on the x-axis. And then because our radius was positive, we go towards that terminal side, 4 units towards that terminal side. For the point negative 4 comma positive 3 pi over 4, so we go to positive 3 pi over 4, our radius is negative. So instead of moving towards that terminal side, we go in the exact opposite direction. Be careful here. It's really easy with these not so much the denominators, but these lines. These lines, sometimes when you think you're moving in this direction, right? You might have accidentally gone over one of these lines on accident. So make sure that the denominators match up. If you are on a pi over 4 angle here, when you go in the opposite direction, it should be a pi over 4 angle down here. So if you're going the opposite direction from pi over 6, you would be going to the other pi over 6 angle in this direction. All right, the case where they're both negative. You can do the negative 3 pi over 4 just like you've always done, negative going clockwise. But this terminal side here, you are no longer moving towards the terminal side. You are moving away from the terminal side in the opposite direction. So 5 pi over 4, you're moving towards pi over 4. All right, let's do some plotting points. Plot the points on the paper. Here we go. All right, so we're going to plot the point 4 comma 5 pi over 6. So you're really starting with that 5 pi over 6. Your theta is 5 pi over 6. That's where you need to start. So I'm going to come here and draw my 5 pi over 6. Boom. There's my theta. And my radius is positive 4. So that means I'm moving out 4 units on the polar grid. So 1, 2, 3, 4, right here. Boom. I can label it. I won't be lazy. 4 comma 5 pi over 6. Again, like I said, sometimes it can help to draw that. If you're using Notability, it's really easy to do this. Sometimes it can help to kind of highlight where that 4 is to make sure you've actually gone out 4 units. All right. So then let's see, -5 comma 5 pi over 3. So our theta is 5 pi over 3. We're always starting by looking at that. So let's see, 5 pi over 3 right here. Our radius this time is -5. Because it's negative, we're going to go in the opposite direction of the angle. Opposite, I can finish writing that word, opposite direction of angle. So the angle would typically go outward, would go this way. This is 5 pi over 3. In the exact opposite direction, I'm looking, by the way, at the pi over 3 angle in quadrant 2, so 2 pi over 3. In the opposite direction, I'm going to go 5 units. It's 5 units in the opposite direction. So we have 1, 2, 3, 4, 5. So this right here is the point, -5 comma 5 pi over 3. Down to here. All right, we have the angle of pi over 2. Theta is equal to pi over 2. That's this side right here. The R value is negative, which means we are going backwards. This is back 3. Opposite direction 3 is really what it means, right? So the opposite direction of pi over 2, just straight down this way. We're going to go back 3 units on that line. So 1, 2, 3. -3 comma pi over 2. Moving to the next one. -3 pi over 4, or sorry, 2 comma -3 pi over 4. So your theta value is -3 pi over 4. And you might be good with negative angles and you might be able to figure this out real quickly. And if you can, that's great. But here's a little trickety trick. And we will get into this a little bit more in this section, but a little trickety trick here for you. The point doesn't care how you got there. As long as you have the correct terminal side and the correct radius, you're going to plot the correct point. So if this angle here bothers you, if you don't like a negative theta value, no problem. We can find a coterminal angle that exists within 0 to 2 pi. You can just find a coterminal angle by adding 2 pi to it. This is going to give us a positive coterminal angle. So theta is really the same as 2 pi. Again, we've done this kind of mental math before. This is the same thing as 8 pi over 4, right? So -3 plus 8 is 5. So this is the same thing as 5 pi over 4. So if we plot this angle, it's the same as -3 pi over 4. So 5 pi over 4 right here. Now, our original angle would have obtained it by going this way. It doesn't matter how it got there. It doesn't matter which way it went to get there. The terminal side is all that matters there. To prove that this is right, this would be -pi over 4, -2 pi over 4. This would be -3 pi over 4. So indeed, this is what you would get to with -3 pi over 4, but sometimes easier when you have a positive angle, right? Our R value is +2, so we'll go out 2 units on the terminal side. So 1, 2, right here. This is going to be the point 2, comma, -3 pi over 4. All right, 2 more, and not bad, right? These should be pretty straightforward problems. They're not meant to be tricky. They are meant to be very straightforward problems. All right, once again, we have a negative angle here, negative 5 pi over 6. If you're good with negative angles, you can just use that angle and plot that terminal side. If you're not, boom, plus 2 pi. Again, remembering our mental math, 2 pi is the same thing as 12 pi over 6, double the denominator. So negative 5 plus 12 is 7. So this is 7 pi over 6. 7 pi over 6 is right here. We would have obtained it going this way, but it doesn't matter. Our radius in this case is negative, which means we're going in the opposite direction 6. Back 6. So I'm going to draw my opposite direction. I'm making sure that I'm still on a pi over 6 angle, and I am. I'm going back 6 units. 1, 2, 3, 4, 5, and 6. And there's that point, negative 6 comma negative 5 pi over 6. Finally, last but not least, we have this guy here. Theta is equal to 11 pi over 3. This is different. This is like a problematic angle in a different way. 2 pi would be the same thing as 6 pi over 3. So 11 pi over 3 is outside of the first revolution. And you're totally welcome to, start counting where this would be without changing the angle at all. But again, sometimes adjusting that angle makes it easier. I'm going to subtract 2 pi from 11 pi over 3, and that'll give me an angle in that first revolution. So this would be 11 pi minus 6 pi, which will be 5 pi over 3. And our R value is positive 7. So we're going out 7 units there. 1, 2, 3, 4, 5, 6, 7. Right down here. And this is the point, 7 comma 11 pi over 3. And I guess I'll just draw in how you would have, that's how you would have obtained that angle if you had gone the full 11 pi over 3 around. Again, doesn't matter how you got there, but I think it's important to bring all the concepts together. All right. So that's that for plotting polar coordinates. It shouldn't be that bad. Should be pretty straightforward. In the next video, we're going to talk about equivalent polar coordinates, which ties in really nicely with this idea we have going right here. All right, I will see you in that next video. Bye.